Welcome to this episode of Fraud Talk, the ACFE's monthly podcast. I'm Emily Primeaux, Associate Editor of Fraud Magazine, and I'm joined by James Ruotolo. James is a director at SAS Institute and is one of our featured experts in an article featured in the July-August issue of Fraud Magazine. In that article, and here today, he'll be discussing how artificial intelligence and machine learning are impacting the anti-fraud profession. Thanks for joining us today, James.
Thanks, Emily. Happy to be here.
So why don't we start with you telling us a little bit about yourself and what you do at SAS?
Sure. Happy to. So my responsibility at SAS is to help companies with their fraud and financial crimes challenges. And SAS as a company has been around for over 40 years and sells business intelligence solutions and analytics capabilities. And so over the past 15 years or so, we've really focused on developing solutions that leverage those SaaS analytics tools to help solve a particular fraud or financial crime problem. So typically work with financial institutions, insurance companies, healthcare organizations, a number of different industries to help them detect fraud or detect money laundering or find suspicious activity.
So that's the basics, but to get more into the fraud aspect of things, in the article that is in the July-August issue, you talk with me at length about artificial intelligence and machine learning and how that's starting to impact the fraud profession and our space. If you could start by telling us a little bit about how you think technology is influencing the future of the anti-fraud profession, I think our listeners would be interested in that, and we can go from there.
Yeah, we see folks on a different spot on the maturity curve from an analytics standpoint. So a lot of organizations maybe start with business rules and have some very straightforward rules that are set up to catch certain types of behavior. And then oftentimes they'll try to implement some more advanced analytical methods once they get comfortable with those rules. So we use a combination of techniques to help detect fraudulent activity. And so we leverage those same business rules, but we often add supervised predictive modeling, for example. If we have a data set of known fraud outcomes that we can use to train a model, then we can use that information to help predict the likelihood of fraudulent activity in future transactions or policies or claims. We often include other techniques like anomaly detection that look for anything that's an outlier, not similar to its peer group. And that helps us because business rules and predictive modeling are really good at finding the types of fraud that you already know about, but they're not as strong at finding the types of fraud that are new or emerging. And so those unsupervised methods like anomaly detection, network analytics really add value in detecting those new and emerging type of fraud schemes. So we combine all that stuff together and then be able to produce a holistic fraud risk score for a given policy or transaction or account. And that's really the approach that we take. Increasingly, organizations are looking at artificial intelligence and some of the other machine learning techniques to help automate some of that process.
The supervised predictive modeling, what is that?
We call it supervised in that there is something that's training the model or supervising the model. And so usually that is a historical set of transactions or whatever you're scoring, claims where fraud has been identified. So we have some examples, if you will, of the types of things we're trying to find. And then the model looks at that and tries to find what are the common denominators amongst those fraud cases that we've seen before, and then builds capability to detect the same type of behavior in future transactions. And so that supervised modeling is very powerful and can be very accurate, but it's dependent upon the training data set that you provide.
Okay, so that is kind of one step before this artificial intelligence idea. It's not quite self-learning yet, the supervised predictive modeling?
That's correct. So the supervised modeling requires you to go through that step of doing the training. And so when we look at artificial intelligence and specifically machine learning, it's that the machine is actually able to learn itself over time. So as you implement a model and you give it feedback by identifying this is a true fraud or this is a false positive, it's constantly updating and finding improvements that it can make to give better results. And so it's sort of doing that supervising and that training on its own. And that's why we call it machine learning, because the machine is actually learning how to improve as it goes forward and it's used.
Now, machine learning is a subset of artificial intelligence, right?
That's right.
Is there a difference between the two?
So the whole concept of artificial intelligence is really to have computers do tasks that human beings typically have had to do. And so that's a sort of very broad definition. And machine learning is a very specific example of that, where we can have that machine do the learning that that a human would normally have to do in order to influence a model. But there are lots of other components. You probably have seen demos of text-to-speech technology and some creative things that companies like Google are pushing out now that are really cool forms of artificial intelligence. Being able to play and win games like chess and Go and things like that. So there are a number of different applications, but as you point out, machine learning is one subset that we tend to leverage quite a bit for fraud detection.
Can you give an example of maybe a case or a specific type of fraud example that machine learning could be helpful detecting or was helpful in detecting the fraud earlier on than your older data analytics would have?
Yeah, the benefit really to machine learning is that constant improvement that I mentioned. And so right now, typically when you deploy an analytical model, you have to spend a fair amount of time doing the care and feeding and constantly updating it and looking at the output. And if you can automate that and let the model continue to improve itself over time, obviously you have the chance to get that into production faster and help catch more fraudulent activity. And so, one of the areas where we see a lot of benefit to robotics or machine learning, robotic process automation is a hot topic right now in the anti-money laundering world, where they have a very high volume of alerts and a very low tolerance for missing stuff. The regulators typically aren't too happy if you're not catching money laundering activity. And so being able to look through all of those alerts, we're looking at applying robotic process automation to help evaluate the alerts once they're produced and then automating some of that triage work. And so that would allow you to handle a much greater volume in a much faster period of time rather than having a whole bunch of analysts looking at those manually. So that's been a very hot topic.
I've heard that term before, robotic process automation. It doesn't make it into the article, but could you explore maybe a little more in depth what that looks like?
Yeah, when we're looking at robotics sort of as an aspect of artificial intelligence, it's trying to automate those tasks that a human does. So it's one thing to have the quote unquote decision-making capability aspect of artificial intelligence, and then another to then automate that process. So I now have a bot, if you will, that will be able to work its way through a number of transactions or alerts and then actually triage them and make a decision and dispose of them in an accurate way as a human normally would. And so obviously that's a force multiplier. You don't have to hire another army of analysts to do all this work. You can move through much greater volume much faster. And that, particularly in the AML compliance space, where the stakes are pretty high, if you get a fine from a regulator, there's a lot of value there. And so that's where we're seeing some of the early adoption. But from a fraud detection standpoint, there are myriad use cases right across a number of different industries where we're looking at applying that as well.
You mentioned when you were talking about that these technologies make it so that you don't need an army of analysts. And I think some of the concern in this day and age is that robots are going to replace humans, and are we going to have jobs? I believe actually one of our keynote speakers at our conference in June, Martin Ford, he's a futurist and AI expert, and his book is about robotic technology and how it's affecting the workforce. And kind of to ease some fears, but also to put some perspective on it, we have to have humans working with these processes, correct?
We do. And we often see people that are concerned about that very issue, is that if I invest in some technology, I'm going to have to, get rid of some people. And in almost every case, our customers see the exact opposite, is that their investment in the technology actually requires an additional investment in human capital. The reason is we typically find the technology helps them identify more stuff to do. And there are some certainly, heavily manual processes that we can automate and accelerate, and that may result in some more efficiency, and maybe you need some less people for those tasks. But you're also going to need more investigators to go out and follow up on the leads that are generated. I think what we're going to see in the future really is we're going to need different skill sets. So it may not be all, adding more of the same types of resources that you have, but you need more data scientists and analysts and folks that have that analytical capability. And we see that across all the industries that we work in, where we're trying to find people that have that combination of fraud investigation knowledge and experience, but also have a comfort level with the technology and analytics. And I know the ACFE is doing a lot to generate a new curriculum around more and more training on analytics, right? Because that's a hot topic, and I know there's a strong interest there.
We here at the ACFE especially talk about how important it is to approach fraud from a preventive standpoint. losses will be less and the impact to your organization is a lot less. And we mentioned briefly about how these data analytics and technologies can get ahead of the fraud. Could you give some specific cases or examples of how it could do that and exactly why it's so important for prevention?
One of the biggest reasons folks have approached us is to become more proactive in their posture towards fraud detection. And a great example is an insurance company that we work with. When they would manually identify files for investigation, they were averaging 60 and 70 days from the time a claim is filed till it's identified and referred to the special investigation unit. And then they would investigate it, and ultimately some of those cases would be confirmed fraud. And hopefully they're able to impact and save some money by not paying those claims. But that time window of 30, 60, 70 days until they get involved, there are often bills that are submitted and paid in that intervening time. And certainly, if you can get involved earlier in that life cycle, you've got a better chance of impacting that and having a successful fraud investigation. And so by implementing some of the technology that we're talking about, that same customer is able to identify those claims within 2 days of them being filed. So they've saved, a month and a half of time where they can actually get involved earlier and prevent those payouts and save that money. And so it's allowed them to become much more proactive. And that's the typical approach that we see for most folks that we work with, is trying to get more proactive and more aggressive in their stance towards detecting those types of activities.
Now, in the industry, and when I've read up on machine learning and AI, I see the term false positives a lot. And I feel like it's important to kind of describe what those are and why it's important that we recognize them.
It's a common term. I don't know if everybody thinks through exactly what it means, right? So in our world, a false positive is simply something that we identify as suspicious that turns out to not be. The goal is to try to minimize those so that you spend your time just looking at and investigating the ones that are really suspicious and ultimately turn out to be fraud. And if you have a very high false positive rate, it's very costly because you're trained in a fairly expensive investigative resources. You usually have limited capacity. You want them to spend their time on the most valuable things. And what's a challenge in building analytical models for fraud is that for most scenarios, you have some known outcomes. These cases historically were fraud and these cases were not fraud. But in organizations where you haven't been doing a good job at detecting the fraud historically, your population is actually, here are the known fraud cases, and then here's everything else, which is non-fraud and the fraud that we didn't catch. Mm-hmm. And so that makes it harder to properly train a supervised model with the process that I described earlier. Some of those other techniques that I mentioned can be helpful in helping ferret out that stuff that you've not been able to discover in the past.
To get specifically to SaaS, you mentioned robotic process and automation, supervised predictive modeling. What other tools are you working with or deploying? Some that you have been doing for years and maybe some new ones that you guys are excited about?
Sure. We do quite a bit with social network analysis, which is some folks might refer to it as link analysis, where we're looking at the relationships in the data. And doing that obviously can provide a lot of value from an investigation standpoint, but it also provides a lot of value from a detection standpoint because we can run analytics on the network itself. And your number of degrees away from another entity or from someone else that may have been known to commit fraud in the past obviously can influence the risk score for a particular entity. So we do quite a bit there. We also do a lot with text analytics, unstructured data, very powerful source of information. Some estimates, 80% of the information in an organization might be in unstructured form. And so really to build the best fraud detection models, you need to be accessing those unstructured data sources.
What is unstructured form?
So a structured data form would be something that's in a database. So it's rows and columns in tables. Unstructured form is something that's typically, an example would be some type of text. So if you have large note fields and things like that. Other forms like audio and social media data and all that typically are in unstructured format. So we try to get it into a format that the machine can read. And then we have to use our text analytics technology to be able to extract the useful information out of those sources. And what's really important there is not just text mining where we're looking for keywords, but also sentiment analysis, where we're looking at the meaning in a sentence or in a paragraph so that you can understand the context of those words. And that's really critical. And that's a much harder thing to do because the machine has to be able to understand human context. And so that's part of that AI approach that we talked about earlier.
Yeah. So I guess with the AI approach, you would need to probably create some sort of baseline first of communication. And then from there, the machine learns over time how people communicate or how transactions are processed and the information within those transactions, what those mean, correct?
That's right. What we've done historically is we have a standard dictionary that we use that, for the given language that we're talking about. And then we typically have a custom dictionary that includes a lot of the maybe vernacular that's used specifically to that industry. Or for example, we work with a lot of insurance companies. People, when they enter their notes on a claim as an adjuster, don't always write in full sentences with proper grammar, right? There's a lot of jargon that's used. There's a lot of abbreviations that are used in a given company. And so we build a custom dictionary that helps the computer understand what all those things mean. And then to your point about machine learning is we're doing a lot of that manually today. The future iteration of that will be to help let the machine learn on its own what those things mean and continue to enhance its accuracy. So we have a little bit of both right now, but there's a lot of value in doing that upfront work so that you can extract good information from the unstructured text.
So in some ways, the machine might pick up on some jargon or slang that didn't originally get put in by a human just because they see it over and over again. And then the machine would say, oh, this is typically used in this capacity and it's a positive term and we don't have to worry about that, right?
That's right. And today the software can help us identify these are terms that it doesn't understand. So it'll give us a list of, you didn't tell me this in the dictionary, right? So you need to clarify. In the future, we're looking to automate some of that work so that it can sort of figure out the context, right? And go through enough iterations. The challenge a lot of times with these approaches is you need pretty large data sets. It needs a lot of examples to be able to learn. The good news is we're producing more and more data at accelerating rates every day. So it's a problem that comes almost with its own solution.
All of this is great, but our fraud examiners aren't all data scientists. They're not all experts in this field, but I'm sure they want to use data analytics in some capacity, or if they haven't, they might decide this could be really helpful when I'm investigating fraud. What would your recommendation be for them if they want to understand the technology or get involved with the technology?
Yeah, that's a great question. And I think that we've got on both sides, we've got folks that are great examiners or investigators, maybe not as comfortable with analytics or technology. And then we've also got data scientists that aren't as familiar with investigations and the methodologies that we would use as CFEs. And so, really the answer is to partner with those folks that are on the other side of that fence. So we see a lot of organizations have developed data science divisions or departments, and they've hired these great analysts, but they really need to train them in the business context of what it means to do an investigation, what are the types of indicators of fraud that we would look for. And so it's really, find the folks within your own organization that maybe have that skill set and find out what they're doing and partner with them. And the other one is, seek out some additional training. So I know that there is an investigating with data analytics course that's available from ACFE. I know that there's a lot of content in the agenda and the various conferences that you host. So plenty of opportunities to learn more about that space. And certainly reach out on social media or connect with some of the folks in the industry or in the association membership base that have that experience as well. And, folks are welcome to contact me and my colleagues if they have some questions and would like some help there.
Is there anything else that you think our fraud examiners should know when it comes to this technology in this space that we haven't talked about?
I think it's really analytics is a big driver, and it's going to be an increasingly important focus of anti-fraud programs going forward. And so I would just say, take a look at an assessment of where you think you are on that analytics maturity curve, and then, develop a strategy for sort of moving along that path and figure out how to take advantage of more advanced analytical techniques. And it's not about a particular software or something you have to buy necessarily. Sometimes it's just about a mindset and taking advantage of the resources that you already have. have and applying those in the right way. So like I said, a lot of great training, a lot of great material that's available out there on the web and through the community that you work with here at ACFE. And so really try to take advantage of that.
Thank you so much for joining us today, James. It was a pleasure having you actually here in the offices and getting to do the podcast in person.
Thanks. That's great. Happy to be here.
And thank you for listening to this episode of Fraud Talk. You can find this episode and all episodes of Fraud Talk on acfe.com/podcast, on Spotify, or wherever you get your podcasts. This has been Emily Primeaux, signing off.